All right. So your page 3, what I found is that I want us to talk more, have some more in-depth wording of interpreting your intervals. When I was looking at the past exams and how we want to interpret intervals, there was some very subtle wording that I thought was good, was very confusing. And so I wanted to give you some techniques and strategies to be able to have a way to interpret an interval and a confidence level. Okay. So now, before we get started, let me ask you this. We're on page 3. So I want you to think in your brain right now. What is the purpose of an interval, a confidence interval? What does that confidence interval do? I'll start off by telling you that an interval is a range of plausible values that a range of plausible values that do what? Okay, odds tell the evens. Wait, let's see who goes. There we go. Odds tell the evens what that range of plausible values is supposed to be doing for you. Okay, do that. What is an interval doing? What do you think?
Tell you like on this, like where the cutoffs are. I forgot the word.
The critical values.
Yeah.
The range is related to that, but I don't think that's like what that range is doing. So let's take a look. Okay, so what did you think? What is this interval supposedly doing? This range of plausible values. You are making that. What is it supposed to do? Hopefully what? Yes, very good. Give you a reasonable estimates true parameter, or we've been using proportions. So it's going to, so we hope it estimates true P. Very good. We are saying things like, I'm 95% confident that the true proportion is between this number and that number. Okay, that was our interval interpretation. But confidence level is having has got some issues with it. And so I want to talk about some of the things about a confidence level definition that can be confusing, because let me just give you a for example. If we scoot on over to page 4. So will you do that for me real quick? Oh, wait. What page is this? Is this page 4? Inverl. Oh, the other one was 2. Sorry, my bad. Okay, I knew there was something wrong there. So this is actually 2. Okay. All right. So if you scoot over to 4, because we're going to end up having pages 4 to 6, I have a couple of, I wanted to fix a couple of things and then talk to you about something real quick. On answer choice A, cross out of time that. Okay, cross that out right there on answer choice A. And then we'll do that on answer choice D, of the times that. Cross that out on answer choice D. Okay. So those needed to be changed. Okay. So what I want to do is I want us to read the problem, and let's just look at answer choices A and B only. So I want you to just read the problem and read answer choices A and B and see what you think about that. So I'll give you a moment to do that. So add choice C. Take a look at C and see what that says. Read C. So I don't know about you, but the first time that I started doing this and I read through all of those answer choices, I'm like, okay, those sound good to me. Sure, I like it. And only one of these, A through E, is correct. And so it took me a while to really target and pinpoint some specific things for you to look at to find the wrong ones. Okay? So I've kind of over the years determined what wording we can target that we know is going to throw us off that are wrong interpretations. So that's what we're going to discuss right over here on this page. And in order to start it, I'm actually going to do an analogy. And this analogy is going to be a story about a tree. And some people are good with analogies, and you're going to be fine with this story. And some people are going to be like, what the heck are you talking about? This is crazy. You're weird, lady. Just give it up. Okay, so but let's just go with it. Let's see. Okay, let's just go with it. All right, so remembering that an interval is an estimate to estimate what true p is. Okay, all right. So there is a tree in my backyard, and your job is to find its location by shooting a net gun. You know, like a Nerf gun, but instead of shooting out the Nerf, it's going to do like a net, to try and catch something with the net. Okay,
Wasn't that in Jurassic World?
maybe. I don't know, maybe. Okay, so we're going to shoot out a net in an attempt to catch the tree. So at this point, what's the analogy of what the tree represents and what the net represents? Can you see where I'm going with this? So what's the tree? Yay! Okay, so the tree is representing your true P. Okay, there you go. What is the net representing? Not your sample, but your interval. See, it's not just like a particular point estimate, it's your interval. Okay, cool. So now you're like, well, duh, why can't you catch a big old tree with your net? Just shoot it at it. Okay, so here's the catch: the tree is invisible. Now I know that's not realistic, but but what do we know about true P? I mean, do we know true P all the time? No. So that's why I'm using this analogy that you don't know where true P is. You don't know where the tree is located. The tree is invisible, and you got to shoot a net and try to find it. Well, when we try to find true P, we take samples to kind of approximately locate it. So our leaves that fall to the ground and then subsequently get dirty show up from the dirt on the ground on the leaves. That's our sample hints. Okay, so we kind of have an idea of where the vicinity to shoot our um, net. We just don't know exactly where that tree is. All right, you see what's happening? So we are all going to use the same size net. It's kind of like common denominator. We can't have some people using a size 80 net and some people using a size 95 net. By the way, how would you relate a size 80 net to our size 95 net? The size 80 net, is it bigger or smaller? Yeah, the size 80 net is smaller. Our size 95 net is bigger. Okay, so see that coincides with bigger confidence, bigger interval. Okay, bigger confidence, bigger interval. Okay, so we all need to use the same size net. We can't just willy-nilly have some 80% intervals and some 95% intervals. They all have to be the same size intervals, okay, with the same size sample, by the way. All right, so this represents our 95% confidence. So we are 95% confident that our 95% net, size 95% net, will capture our tree. Okay, so there we go. We get the picture of what's going on. So let's go through some things to look for some false understandings. Okay, so here's one situation. Okay, so we know that everyone who casts the size 95 net can say he or she is 95% confident that his size 95 net will capture the tree. Okay, I think we know that. You're 95% confident that your size 95 net will capture the tree. All right. But here is where one of the issues comes into play. Would you agree that true P is a set value and does not move? Do you agree with that? The true proportion of Hershey's Kisses that land on their base is a certain value, and it doesn't change. That true proportion for all Hershey's Kisses is that number. So do you agree that the true P is a set number and doesn't move? Okay, so is our tree. Hence, that's where I came up with this analogy. Our tree is stationary and cannot move. Just like true P is a set number and cannot move. Okay, so here's where the problem comes into play. You have to think in terms of, did your net catch the tree? Did your net catch the tree? You cannot think in terms of, did the tree land in your net? Okay, because the tree can't sometimes be one value and sometimes be in another place, sometimes be in one place. So look what happens. Therefore, you cannot think like this, that there's a 95% chance or a 95% probability that the tree is in the net. Of course, you also can't say 95% of the time the tree is in the net. If you say 95% of the time the tree is in your interval, what is that really saying? 5% of the time it is not. Hence, you just told me the tree moved. That's a problem. Okay? So you cannot ever refer to as a chance or a probability or a percent of time that the tree is in the net, because the tree doesn't move. Okay, so that's one major problem. That's actually, strategy number one to look for. The true P cannot move. Okay, no, percent of the time or probability of being in the interval. Okay, so that's one idea that you can find that they will lead you to believe, and that's wrong. Okay, here's the next one. We have to keep in mind that all of our intervals are based on how confident we are we capture the true P. There is no bearing whatsoever on if our net has other people's nets in it or other people's samples. An interval is not about our other people's samples or other people's nets in our result. No, there's no discussion about other people's intervals or other people's p-hats being in our net. That's the next one. Strategy number two, look for the wrong statements that say sample p-hats or the other sample intervals. Not in our interval. That's the other second major thing that they'll mislead you with wording on. Okay. The third thing, and I actually just kind of came up with this one today, they'll change the units of the proportion. For example, our first problem is about the proportion of on the next page that we're about to do. It's about the proportion of Aledo High School students, and sometimes it talks about the proportion of time. So that just changed units. If they talk about the proportion of Aledo High School students versus the proportion of time, they've just changed the units, and that's a no-go. All right, So I think if you understand these three topics, we can then kind of work through and muddle through the intricacies of the wording that you're going to be presented with and find out which one is the correct interpretation of confidence levels and intervals. Yes. Problem number 2 or strategy 2. So okay, here's a picture because in fact I wish I had pulled this up. You know all of our intervals that we made with our, okay, you know our Hershey's Kisses lab? Okay, we all had these intervals. Well, what would happen if this was my interval right here? Okay, so a a interval or confidence level is not interpreted in terms of the proportion of other people's intervals that are in mine, because mine could be an outlier and not even have any bearing whatsoever on other people's sample results. It's always, intervals are always in terms of if we capture that true P or not. Did we capture that true P or not? Okay, which brings us to the top of the next page. So here's our standardized statements. I'm 95% confident that my size 95 net will contain the will contain the true P. And then here is confidence level. If many people cast their nets, about 95% of the 95, they have to be size 95 nets. It has to coincide. You can't go willy-nilly on all the different sizes of intervals. Will contain the tree or the true P. So real quickly, this might help us as we go through some things. Here's a quick little confidence level song. We know our tune Smelly Cat from Friends. How many, and what size interval? How many contain the true P? So about 95%, that's how many, and what size interval? How many contain the true P? Okay, so that can help us in kind of a check of looking for what we want. Let's move on to this. Let's go back to this first problem here. All right, so first I want you to define what the parameter is. What true proportion are they attempting to estimate in this problem? Define that. So read the problem and write down what true P are they attempting to estimate in this problem. All right, so we want to estimate the proportion of Aledo High School students who stop and pick up food or drink on the way to school or before school. Okay, so I'm going to tell you right now, answer choices A and B are both wrong. I'll tell you that. A and B are both wrong. I want you to identify why. According to the techniques and strategies I taught you today, what's wrong about them? Okay, let me give you a minute to do that. Okay, ideas, what's wrong with A? Yes, very good. It says 90% of the time the true P is this much. Well, what is that then implying? 10% of the time the true P is what? something else. So that's saying the tree is sometimes here and sometimes somewhere else. The tree can't move. The true P is either in it or not. Okay. All right. B. 90% of all Alito High School students stop and pick up some type of food or drink before school, 35 55% of the time. Well,
It's implying that 90% of all Leader High School students and not 90% of the 100 students.
no, that's not true because that is what inference is. Inference is implying about all. So that's not the problem. It's not that it's about all. Aha. Yep. 35 to 55% of the time. What the heck? I thought our proportion is about the percent of students, not the percent of time something happens. See? They just changed units on you. They just changed units. Okay? I mean, basically, when they said 90% of the students, they said P is 0.90. That's kind of what that was saying. So that's all messed up too. But so they did two things bad there. All right. I'm going to let you take a look at C, D, and E and see which of those you can find to be true and what's wrong with the other ones. Okay? So do that. Hey, how are we feeling? What are we liking? Any ideas? Do we need to go through each one? Okay, what about C? Anything? 90% of all random samples of 100 students from the Alito High School sample would result in a sample proportion of students who stop and pick up food, blah, blah, blah. So that the sample proportion of 0.35 to 0.55. What's that? What? So it's not saying that true P is moving, but it is discussing the P hats being in my interval. So it is about, that's the problem. It's talking about all the other P, 90% of everybody else's P hats are going to be in my interval. Hello, didn't we have this discussion? Didn't we have this discussion? This is not about other people's P hats or other people's intervals being in mine. That's the problem. Okay. All right. Moving back. Okay. So there's no go on that one. D. 90% of all random samples of 100 students obtained from Alita High School would result in 90% confidence intervals that contain the true proportion of students that stop some type of food or drink before school. It does not mention 0.35 to 0.55. Does that make it wrong? So let's talk about, this is the interpretation of confidence level. How many, and what size interval, how many contain the true P? Well, let's see. How many? 90% of them will result in a what size interval? How many contain the true P? See? So it wasn't even about, this was not an interval interpretation. This was a level interpretation. So 0.35 to 0.55 wasn't even necessarily in this. Let's look at E though. E says approximately 90 to 100 of the Aledo High School students in the sample, so 90% of the students in the sample, will stop and pick up some type of food 35 to 55% of the time.
It says 90 to 100% of the students.
No, oh, it does say 90 to 100 of them. Okay, that's interesting. Yeah, I didn't think about that. If it had said 90 of the 100, would that have made it correct then? No.
No.
35 to 55% of the time. Didn't we not like that right here in part B? 35 to 55% of the time. That was a change of units. This is a change of units. Okay. Furthermore, you know what it talked about? Approximately, if it said 90 of the 100 students in this sample. Okay, so let me see here. How did I make this interval? I made it from my sample. So anyway, that one's just all messed up. Has lots of things wrong with it. Okay, so what's the answer? D. All right. So I've kind of baby stepped you through how to handle some of those strategies. We've got a good 6 minutes or so. Let's see if you can't step yourself through the strategies and techniques here on number 2. So go for that. Let me give you about 3 or 4 minutes to do that, and then we'll discuss and see how you did. What is our P in this one? What are we attempting to approximate or whatever? Yeah. The proportion of the alfalfa plants that are infected with the weevils. Okay, so how about A? What do we like it, or is there something wrong with it? You're pretty sure there's something wrong with it. Okay, what do we think?
Depends on how many there are in total.
It's talking about the sampled results, and it's saying that the sampled results are going to be what? In our interval. Excuse me. Are these sampled results necessarily in my interval? Maybe, maybe not. I don't know. That's not what this is about. So that's what's wrong with that. Okay, so A's out. Okay, B. Let's see. 95% of alfalfa field sampled. It's talking about the sampled stuff is going to have the same, is going to be my results. Furthermore, it says the sample, okay, yeah, that is true. It may be different. Okay, but this first thing again is the same problem as what was in A. All right, C. If we repeatedly sampled this field, I like it. Taking sample size 800, same size samples, and we construct the size confident 95% confidence intervals. So that's the size. What size interval? How many? How many? Approximately 95% of them. I like it so far. What? Contain the true P. Record scratch like wrong-o. That's where it went wrong. It's saying about 95% of them are going to make 95% intervals that contain my p hat. Heck no, not necessarily. D, if we repeatedly sampled this field, taking those samples, we make 95% what size intervals? How many? How many? Contain the true p. And it defined that true p correctly. I'm liking it. And what's wrong with E? E is identical to C. It just wrote it as 105 out of 800. Okay, good job. So you're going to finish pages 4 to 6.